Hey there, everybody. For this example, we are going to start out by looking at the counted loop. Remember, the counted loop is unusual in that, number one, before the developer goes into the live environment, so before this is ever even run by a user, the developer is going to know something that is really uncommon as far as development goes. The developer is going to know the number of times the loop is going to be undertaken. Really unusual. So that requires that we have a good bit of knowledge about what is going to happen going in. So really what we're saying is a counted loop example is going to have that comes with it a really rigid set of rules. So for this particular example, your doctor is having you check your temperature every hour on the hour for the next 24 hours. You are going to develop an algorithm that takes the hourly temperature, averages them, and then finds the highest temperature over that time frame. So the things we have to know are we need a temperature check, and that happens every hour on the hour for 24 hours. So that's going to give us an idea for how many times this loop has to actually be undertaken. We also know that we have to take the temperature, we have to average them, and find the highest temperature. Now, what I have not included here in the direction set is something that you as a developer should seek to provide anyway, is that you'll notice the requirement does not specifically state after we find the average and the highest temperature, it doesn't say that we have to display that to the user. Now, what I'll tell you is if we don't display that any actual process has been undertaken here, if we don't display that there's a result to the user, they are not going to find that they have interacted with this program in a satisfactory way. So that's not something we want to do. From the description here, we as developers have to kind of extrapolate those last two components, which would be to display the average and display the highest temperature. So what we do know is we need a module, and we have to give that module a name. So we're going to call it hourly temperature. It doesn't really matter what you call this. Again, you've got a little bit of leeway there as to what the name of your module is going to be. Because I'm going to fail to mention this otherwise, I am in Sublime Text. You can tell up here in the upper right hand corner that in fact I have not paid for this version, which is something that you can follow along with doing at home as well. You can simply continue to evaluate this as long as we have class and make a decision in, 16 weeks as to whether or not you want to actually go ahead and pay for that. Now, what I'm going to do is just by way of example here, I'm going to mention that there are some variables we know we need or we know we are going to need through the implementation of this particular module. What we know we're probably going to need is a counter. We have to know how many times we're going through this loop. We are going to need to get an hourly temperature from the user. We know that we have to do a little bit of math here. So just in case, I have a temp count variable. I have an average that's going to hold the average temperature, and the highest that's going to hold the highest temperature. Are all of these going to be used necessarily? No, but they're things that I know before I go through here and start developing that I'm going to need to have in order to probably complete my development. Now, as a developer, somebody who has done this before, I can tell you, and this is actually something that we do see in the text, that we are going to have to what is known as initialize our variables. In a runtime environment, so if I was to compile this in JavaScript, if I was to compile this in Java or C++ or any of the other compile time languages, there's no guarantee that when I receive a valuable or a value, let's try that from the top. There's no guarantee that when I receive a value to store into a variable from the user that there's empty space there. There, as a matter of fact, may be something in there already. To go with that, think about just taking a container. So like if you are just going into your basement and for the first time in a number of months, you pick up an empty like Tupperware container. Now, when you put that Tupperware container there, it was empty. It was clean. There was no dust and it's ready to go. This time around, you come down to your container, you locate your container, and you open it up. But this time, there's dust in there. There's a little bit of shelf material from whatever the shelf is on top of it, and there's a dead centipede. Now, when you put the container down there, you thought you were the last one to use it because as a developer or as a human being or as a a sentient person, we simply think to ourselves, I'm the one who put it there. I'm the next one who's going to get it. I'm the only one who has control over that. But really, that's not the case. That variable, or your Tupperware container, is really going to be part of a much larger system that's interacting. So when I put it on a shelf, that shelf is in a much larger, basement, which is a much larger home. When I have a counter or a variable for average or highest, that's me setting aside a variable, a container. And that container lives in a much larger system. So as I'm developing this here, I'm on my Sublime Text. So Sublime Text is one container that each of these containers, counter, average, and highest, is going to be located in. Sublime Text is located inside of my Mac. My Mac has, special storage compartments for each one of the different pieces of the system there. So you can't be assured what is going to be in these containers. Better than leaving that to chance is to actually go through here and initialize all of them or set them all back to 0. So that's what we're doing is we are providing in a default number there. So zeros in this case, and that's going to be just fine. That's what we want. We don't want those numbers to have any influence on what the average is going to be, for example, when we're all done with everything. So next, the rules of good program design suggest that I am going to tell the user what to expect from this particular interaction. So this is a display because, again, a prompt would suggest that we're creating a two-way interaction. We are not quite doing that yet. So for this, and remember this is a counted loop example because we know that we are going to, as this display suggests, check a temperature every hour on the hour for the next 24 hours. So that's letting the user know what to expect from the interaction that we're going to have. So what we need is a do loop. Remember again, because the do loop is going to suggest that we have a known number of iterations that we are going to hit before we are done with this. So again, our keyword do on line 15 there and end do on line 19 here, those are going to go on the same vertical line, and everything that the rest of the code in that code block is going to be indented 1. And again, the nice part about using Sublime Text here as opposed to Word or Notepad, etc., is going to be that Sublime Text is going to help you manage those tab indices, whereas Word simply will not help us with that. So here, inside of our do loop, we are prompting the user. So we are creating a two-way communication. Please enter temperature for hour number, and it's using the loop index here to tell the user what hour number it is. Now, here's something to take notice of. Here inside of our loop initiation and instantiation statement, so line number 15 says set up a loop for us here. We have loop index equals 1 to 25, and that's all we need here to create the following conditions. We are going to, number 1, the condition we're creating is a loop. That loop index number 2 is going to be controlled by loop index. Number 3, loop index will start at 1, and number 4, loop index will terminate at 25. The final thing that this does is it terminates at 25. So this is how this interaction is going to work. I am leaving these numbers for us here just as is, so we can come back here to take a look at this later on. So we are prompting the user to please enter temperature for hour. In this case, when this comes through the loop the first time, it's going to be hour 1. So after that, clearly we have to get something from the user. The thing it is that we are going to get from the user is going to be the hourly temperature. So whatever the reading is that they have at this time. So one of the things that we are being tasked with here is we are going to find if that hourly temperature is the highest temperature. So now what we need to have is a selection. So selection, you'll remember from the previous chapter, chapter 4, is setting up conditions whereby we can reduce the number of different inputs that we get. So we're selecting based on those inputs. So what we're going to have to check for here is with an if statement. And we want to know if hourly temperature is greater than the highest temperature. Remember, we've already set the highest temperature to 0. So if 98.6 is higher than 0, then hourly temperature equals highest. So what this little portion, these 3 lines of code are going to do is evaluate. Every time the user enters in a new temperature reading, that temperature is going to be evaluated to see if it's the highest temperature. And that's all we have to do. So we are getting an hourly temperature. We are checking that against our highest temperature to see whether or not it's the highest, and then we have to continue on. So now that we have our highest temperature, we have to do the other portion of our math, right? We have to essentially go down the road that averages what our temperature readings are. So next what we do is temp count. Remember, temp count is just a variable that I created that I knew I needed just to store some data in. So what am I storing in temp count? I'm essentially just adding up all the temperature readings so that I can take an average later on. So here on line 21, what I'm doing is I'm taking temp count and I am adding to it the value that we just read into hourly temperature. Now, this is what is known as shorthand. This is a shorthand we covered way back in chapter 2, so I'll admit to you that that is a while ago. The other way we could do this is if we had temp count equals temp count plus hourly temperature. What happens here is the right-hand side of the operand. So everything that happens to the right hand of equals is evaluated first. So it's okay that I have temp count 2 times in this particular equation, because what's really going to happen is 2 separate interactions. The first one that's going to happen is on the right-hand side of the equal sign. So we're going to take whatever is in temp count, and we should have set that to 0 before with the rest of our initiations. So temp count equals 0, we can go ahead and add that back here. So what temp count, which is 0 presently, plus 98.5, and we're going to get a number. So that clearly the mathematics on that makes 98.5, and that is going to be stored back here into temperature count. Now these 2 lines, 21 and 22, are identical as far as any system is going to be concerned. So whether or not, and again, pick a compile time language, this is how that's going to work. This on line 22 is the longhand. This on line 21 is the shorthand, and that's just the one I'm going to leave for you out here, is the shorthand. So we're temp count plus equals hourly temperature is perfectly good enough. Now, inside of our loop mechanism, this is actually all we need to do. The first time it's going to come around, that's going to be 1. The second time it's going to come around, this is going to be 2. It's going to go through these actions. The third time 3, the fourth time 4, the fifth time 5, so on and so forth. Now, here's a place to pause really quickly, is our loop index here. Now, 1 to 25, this is going to loop through the iteration 25 times. What I'm demonstrating here is what is known as the off by 1 error. This is one of the most common errors that developers, number 1, step in, and number 2, have to go back later on and go correct for, is off by 1. Because your counter has 2 different places to start. It starts at 1 or it starts at 0. That means your destination is either going to be the number you're looking for, so in our case it's 24, or it's the number we're looking for minus 1. So if I had done loop index 0, I would want that to go to not 24, but in fact 23. The problem here is going to be, if I structure my loop this way, on the first time through, I'm going to ask my user to enter a temperature for hour 0. And that's unusual, right? And the last time they're going to enter a number, I'm going to ask them for temperature number 23, despite the fact that I've already told them that I am going to take temperature readings for the next 24 hours. Now, 24 hours and 0 to 23, actually, that's correct. So 0 to 23 is 24 loop iterations. 24 hours is 24 loop iterations. That's not what the user is going to like. So what we want is 1 to 24. This way, it's correct. So if you start with 0, remember it's n minus 1, the number you're looking for minus 1. If you start your loop index at 1, it will run to the number that you are looking for. So that'll get you through there. Now, the next piece of the puzzle we need here is to get the average for the temperatures. So that means we need a little bit of math. That little bit of math is average. So again, I have an average variable that I have initialized and set to 0. That's going to be temp count, and you'll remember temperature count is just the adding up of all of my hourly temperatures divided by loop index. So here's my loop index, and here I have minus 1. Now that's actually a carryover mistake from the logic we had before. So loop index minus 1 was okay when I thought, on purpose, that this loop had to go 25 times. That's not correct. This math maps to this math, both of which are a mistake. Really what we want is 24 here, and this would be loop index, because the last time this do loop executes, we're going to have a value stored in loop index, and that's going to be the number of times we looped, which is 24. So this math turns out to be correct. Average equals temp count divided by loop index, and that turns out to be perfectly good math. So if we were to look at the problem description right here, we're technically done, right? Because we have taken the temperature readings for 24 hours, we have determined which temperature reading is the highest, and we have determined the average of those temperature readings. But for the user, at the end of 24 hours, they hit enter and nothing happens. That's bad user design. What we want to do is provide the user with some sort of feedback. Let them know at the very least that the transactions they were undertaking have, completed successfully. So what we're going to do is display for the user your average temperature was, and actually display for them the average. It's going to display for them the highest temperature was, and it's going to display for them the highest. And we'll just display one more time for them. There we go. Now, go see your doctor again, please. Those BMWs don't pay for themselves. So this lets them know that there's an action that they're supposed to undertake, and it gives them a sense of completion to the transactions that they've been undertaking here as a whole. So this was counted repetition, where again, you as the developer know, which again is unusual, where you as the developer know how many iterations you're going to have to undertake. Things of note here are here in the loop instantiation statement. That's where we're creating our loop. All we really need in a do loop is this one line, and everything else kind of takes care of itself, which is great. We have loop index. This is going to help us control how many times this loop is undertaken. And we set that equal to the number of times, the range really, for the number of times we need it to undertake that particular loop. So for us, that's 1 to 24. Remember, if you start your loops at 0, you'll have to go to your number minus 1, which is 0 to 23. But in this particular instance, we're using 1 because I can use that loop index number to prompt my user to enter data, and it also helps the user know what to expect as far as how many numbers they've entered already and how many numbers it is that they have to enter until they're done. So that's good user design right there. Inside of our do loop, we can also have selection. So this selection is looking to see whether or not temperature is the highest, and if temperature is higher than highest, then new hourly temperature equals highest, and that's what we've got in there. And then finally, we are doing a little bit of math here inside of our do loop. Now, if you compare this to what we know about the repeat until, or if you compare this to what we know about the do while loops, you'll notice that we don't have to increment our counter. You'll notice that we don't have to have a priming read. You'll notice that we don't have to have any logic in here to make sure that our loop exits correctly. That's again what makes the counted loop a really fine way to go through and develop things, even though it's really not highly likely that you're going to use a bunch of these counted loops outside of testing scenarios.